Module 6, Section 2, Objective 2. We're going to convert a fraction to a decimal without a calculator. So this is the other way around from Objective 1. Okay, reading through what they have. Fractions represent division, right? We've talked about this before. The numerator is divided and the denominator is the divider. There's a dividend, excuse me. To change from a fraction to a decimal, divide the numerator by the denominator. To change a mixed number to a decimal, change the mixed number to an improper fraction and then divide, okay? That's the hard way, in my opinion. You can do like we did before, just leave the whole number, and I will go over that here in just a minute. Okay, but first of all, let me simplify this a little bit. Okay, to change a fraction to a decimal, divide the numerator by the denominator, it says. Okay, so let me show you. This is the numerator, and that's really messy. Denominator. Okay, so I'm going to abbreviate. You're going to divide the numerator by the denominator. Okay, one easy way to remember that, instead of numerator and denominator, is the top goes underneath. The bottom is on the outside. Top divided by the bottom. Okay, so this is what you need to memorize. And if you get that, you'll be fine. Okay, and we'll talk about mixed numbers here when we get to them. Okay, I'm going to delete the one that we already see done for us so that we can do it ourselves. But it says write a fraction as a decimal, leave it in exact decimal form. In other words, use a bar to show repeat. You may remember some of that when you did math way back when, but I'll explain it again when we get to it. Okay, and if you remember what we talked about from the last page, we're going to do the bottom into the top. Okay, so the 7 goes underneath, and the 12 goes on the outside. And we'll put the negative in afterwards, okay? So since 12 doesn't go into 7 at all, we're going to put a decimal. And then add as many zeros as you need. I usually just start with 3 and see where we go. You can add more if you need it. If you don't need that many, that's okay. You can just drop them off. Okay, so now we're going to go 12 doesn't go into 7 like we said, so we're going to use 70. Since we're going past the decimal, this decimal has to rise up to be part of the answer. Okay, so it just goes straight up from where you are. Okay, so 12 into 70. So if you know your 12's times tables, that's great. If you don't, let's do a few problems off to the side. So 12 times 7 is 84. It's too big. So 12 times 6 is 72. It's also too big. So 12 times 5, there we go, 60. So we're going to put a 5 there. So actually, let's change colors so you can see this. We get 60. Now we're going to subtract, and we get a 10. Bring down the next 0. Okay, so now those scratch numbers off to the side are going to help me a little bit, aren't they? How many times does 12 go into 100? 84 is not big enough, so I need to go bigger. Let's try 8. Okay, so we get 96. Yep. And that's only 4 away from 100, so I know that's going to be my answer. So I'm going to put in an 8, and that's 96. Okay, so subtract those, I get a 4. Bring down my next 0. Okay, and I was going to go back to green again, but I'll get a new color. So 12 goes into 40. Okay, 60 is too big, right? So go down again. We get 48. That's not helpful. So go down again. 36. There we go. We need a 3. So 12 times 3 is 36. You subtract, and we get a 4. It's not a 0. We're not done. We still have a remainder, so we have to keep going. Okay, so I'm going to add another 0 and bring it down. And I get 40. Again, which means I'm going to have a 3. Again. And when I subtract, I'm going to get a 4. Again. So this whole process is going to continue. If I add a 0, bring it down, I'll get a 40 again, which means I'll need a 3 again, which means I'll get 36 again, and this will always happen. Okay, it's going to repeat forever. It will never stop. Okay, so let me clean this up so you can see what's happening. Okay, so those 3's are going to continue. It'll be 3, a 3, a 3, and you will never be able to get to the end. Okay, so that's what they were talking about up here. Use the bar to show the repeat. So the actual answer, let's write it up at the original here, is negative, because of their negative. And now down on our answer, we start with a decimal, so I'm going to add a 0 in front of it just because that's what I generally do. So 0.58, and then the 3 repeats. You put a bar over it. Make certain it's not over the 8, and it's only over the 3. So 0.583 repeats. Okay? It's just going to be some long division problems, but it won't be too hard. Okay, next one. 5/20ths. You've got a couple options. You can simplify it first, or you can just go right ahead and divide. Okay, so let's just go ahead and divide because those numbers aren't too bad. So bottom into top, right? So we're going to go 20 into 5. And it obviously won't go, so that's why I left some space here. And let's put in some zeros. I don't know how many we're going to need. Okay, since 20 will not go into 5, I'm going to raise the decimal up to the answer, and now I'm going to go into 50. Okay, so 20 doubled is 40, but times 3 is 60, so it's too big. So I want 40. We're going to subtract. I get 10. Bring down a 0. And 20 goes into 100 evenly 5 times. Okay, so we're done. We didn't need the 0 at the end. And since I have a 0 here, that's an exact answer. I don't need to put a bar over anything because nothing repeats. Okay, so the answer for this one then is just 0.25. And you're done. Okay, there is no trick to using the 2 and the 5 here to make the 2 and the 5 here. That's just a coincidence. If you look over here, see 7 and 12, there are no 7s and 12s over here. Okay, let's do -5/6. Okay, so I'm going to rewrite this already as negative. Now, because 5/6, it's less than 1, right? 5 out of 6 is less than 1. I'm going to put a 0 point already. I know it's going to be a decimal. Okay, so bottom into top. And a decimal and a few zeros to see what we need. Okay, since 6 won't go into 5, I'm going to bring my decimal up. And now I'm going to do 6 into 50. Okay, so 6 times 8 is 48. So that's what we're going to start with. So 48, and we're going to subtract. And we get a 2. Bring down the 0. Since we're not done, you have to keep going. Okay, 6 goes into 20 3 times. That's 18. 6 times 4 is 24, and it's too big. Subtract, we get a 2. Bring down a 0. And we get a 20 again. So we're going to need a 3 again. And we're going to get 18 again, which means we're repeating, right? and I'd have to add another 0 and bring it down. And you don't have to continue. As soon as you know it repeats, instead of writing 3 3s or 5 3s or whatever, if you know it's never going to stop, you can quit like right here when you notice that that 2 is the same as this 2, and you're just going to bring down another 0. Okay? Sometimes it helps to go that one more, bring the 0 down, and then you see it's a 20, and it's like, oh, I've had a 20 before, and it's going to continue. Then, you know, however long it takes you to recognize that it's going to repeat is as long as you need to continue going, okay? And it's going to repeat. Okay, that's an interesting thing. Where do I put the line? Okay, I put it on that 3 up in my problem, but I could put it on this 3, or I could put it on both of the 3's, because 33, 33 is the same thing as repeating a single 3, right? So what's going to be right for lumens? I'm not exactly sure. I haven't tried to type them in incorrectly, or that's the wrong word, different ways to see if they like them. The most often used version is putting the repeat line over the first number that repeats. Okay, so no extra numbers, basically, is what they're saying. Okay, when you type this into your homework, this is really weird. You have to do negative 0.8. That's fine. But now when you get to the 3 with the bar over it, you're going to type bar 3. Okay? If for some reason, and it can happen, let me slide this up, you have a number that looks like this, 0.454545. Okay, you would write that as the 4 and the 5 repeat. So you can put the bar over both of them. When you type that one into lumens, you're going to type negative 0. bar 45, because the 4 and the 5 repeat. Okay, that's kind of using some coding to help it, because you're typing the code that the lumens program uses. That's kind of interesting, huh? Okay. Wow, there we go. Okay. Mixed numbers. They say to do what they have done here. I have added this part. This is my option. Okay, so let's look at just their version. Okay, so I'll make it a little bit bigger so we can look at it. Okay, so they went 5 times 4 is 20, add 1 is 21. Bottom into top. So the 21 is the top, goes underneath, the 5's on the outside. So 5 goes into 21 4 times. 4 times 5 is the 20. You subtract and you get a 1. Bring down the 0. 5 goes into 10 2 times. 2 times 5 is 10. You subtract, you get a 0. Okay? All right. The 4 that was here ends up being a 4 here. All right? You say 4 and 1/5. So your answer should be 4 and 1/5 when you simplify that. Okay? And it is, because 4 and 2/10, those both divide by 2, right? So we get 4 and 1/5. In my opinion, doing that division with big numbers here, because these are bigger numbers, is a lot harder than doing the division with smaller numbers. Okay, and let me show you what I mean. Okay, so I'm going to, actually I'll leave theirs there. Let's do it again below. Okay, so same problem, 4 1/5. I'm going to change it to 4 and now all I have to do is the 1/5 when I divide, because the 4 came over here. So bottom into top. It won't go, so I need to add a decimal and some zeros. Decimal is going to come straight up. So 5 won't go into 1, but it will go into 10, right? So I didn't need all those extra zeros. It's just me. I just have it write 3 because I might need them. Okay, I'm done. I have no remainder. I don't need to fill in with zeros because those are after the decimal. So it's just 0.2. Okay, so this decimal is that decimal. Okay, so I'm going to put a 2 after it. That's it. 4.2, which is exactly what they got. Okay, so if you don't have to do 5 times 4 add 1 is 21, and then when you divide, the 4 shows up anyway, I think it's kind of useless to have to do that. Okay, that's my opinion. If it makes it easier for you because of whatever reason, then do it, you know. I, however, am not going to. Okay, so here we go. On this side, we're going to do equals -1 and, now let's figure out what 7/9 is. Okay, so bottom into top, so 9 into 7. And I'm going to add 3 zeros. Decimal is going to go straight up. So 9 into 70. 9 times 7 is 63. 9 times 8 is 72. It's too big, so 7. I need 63. Subtract, and I get a 7. Bring down a 0. There's a 70 again. We're going to get some repeats, aren't we? Okay, subtract, and I get a 7 again. Bring down a 0. There's my 70. Okay, so those 7s are going to happen forever. So when I bring it over to my answer, I need a bar over the 7. And just a reminder for how you type it in, like that. Okay, next one. This one is -3 and, or positive, sorry, 3 3/8. So it's 3 and, now let's see what 3/8 is. Bottom into top. Okay, 8 goes into 30 3 times, so it's 24. 8 goes into 60 7 times. Bring down our last 0 that I have, and we get 8 into 40 5 times. Worked out perfectly that time. Okay, so the 375 goes back over as part of our answer. Okay, not too bad.